Hello students, welcome to Mathematics in Action, lesson number 5. Now when we are through exploring, we'll be able to use ratio to compare quantities. Write a ratio to compare the number of items in two sets or two parts of a set. Write a ratio using different formats, such as 1 to 5 or even as a fraction. Now, let's examine this beautiful bracelet. What fraction of the bracelet is blue? In order to know this, we need to know how many beads make up the entire bracelet. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many of the 16 beads are blue? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Right you are, 8 blue beads out of the 16 beads. What fraction is that? 8/16? Can that be simplified? Yes. What fraction is that? A half. Awesome. That's a half of the entire bracelet. Now, what fraction of the bracelet is spherical in shape? Let's count those spherical beads. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. So we have 8 spherical beads. So the fraction is 8/16, or we did this before, a half. Awesome. If you wanted to make a bracelet 3/4 of this size, how many beads would you need? Let's find that out. 3/4 of 16. Did you get 12? Awesome job! Well done! Now we're going to examine another bracelet. How many beads make up this bracelet? Did you get 20? Awesome! Now, what is the relationship between the number of black beads and the number of multicolor beads? Well, let's check. I got 15 black beads and 5 multicolor beads. Awesome. Now, if you wanted to make a bracelet just like this one, using blue and white beads, how many beads would you need? Now, how many blue and how many white beads would you need? Now that's dependent on you. Are you using your blue beads to take the place of the black? Or are you using your blue beads to take the place of multicolor beads? You will have to determine. In describing our bracelets, what have we been doing? We have looked not just at colors, but the numbers of each color and the types of beads that make up the bracelets. We have been expressing relationships between two or more quantities. In mathematics, we call this ratio. For example, if we could speak of the number of blue beads to the number of red beads, or the number of spherical beads to the number of shells, the number of girls to the number of boys in a class? Just to give a few examples. Ratios can compare a part to whole. Remember that multicolor and black bracelet? The ratio of the number of multicolor beads, 5, to the number of beads in the entire bracelet, 20. This can be written and conceptualized as a fraction. 5/20. The multicolor beads make up 5/20 of the whole bracelet. Can this fraction be written in a simpler form? Of course it can. 5/20 is the same as a quarter. Ratios can also compare a part of one whole to another part of the same whole, part. Example, the ratio of multicolor to black in the bracelet of 20 beads is 5:15. Ratios can be written in 3 formats. 5:15 using the word to, 5:15 using a colon, or as a fraction, 5/20. So let's summarize what we did today. We looked at ratios using part to whole when we compared multicolor beads to all the beads in the bracelet, 5/20. Then we compared part to part. We compared the number of multicolor beads to the number of black beads in a 5:15 ratio. Then, ratios can be written in 3 formats. 5:15 using the word to, 5:15 using a colon, or as a fraction, 5/20. Now, here's an activity for you to do on your own. Remember that blue and white bracelet that we made? 3 of your friends loved it and want you to make bracelets for them too, just like that one. Complete this order sheet to get the correct ratio of beads for each bracelet. Now, we can use ratio as a comparison in problem solving and decision making. And have fun putting mathematics in action.